Let's talk about getting our CRUD together. First, it's a tiny bit about me. I'm a principal engineer at a company called LaunchScout. I use Elixir primarily in my day-to-day. Also a little bit of Ruby, a little bit of JavaScript, a little bit of whatever else my heart desires. I've posted the link to the code and to the slides, both in the chat, and then it's also right here, this github.com/AndrewX/Prairie. And we're going to talk about CRUD. And so, like any good talk, we're going to start with some horror stories. We're going to be horrified. We're going to do that this morning together. I'm going to share a couple of experiences that I have had that you might be able to identify with. The first is a Ruby on Rails application. If you've worked with that, if you've worked with ActiveRecord, you might be thinking to yourself, yes, we're going to talk about ActiveRecord callbacks. And yes, in short, an ActiveRecord callback is a method that gets run automatically after records are created, saved, destroyed, updated, etc. And I worked with an application where it started by inserting data, and then all of the business logic happened in ActiveRecord callbacks in the name of efficiency and in the name of minimizing lines of code, really. And it was a mess. It was a nightmare. It was extremely difficult to debug anything and to get the database into a state where we could debug anything. And that was a case of data and the application being really hard to reason about because of some architectural decisions made very early on. The second horror story that I'd like to share is an application for managing a business where I was brought on as a consultant. This application had at most maybe 12 concurrent users. And it was a Phoenix and Elixir on the back end, React.js on the front end, communicating through RESTful API endpoints, HTTP requests. And so the every endpoint had its own very, very unique way of rendering JSON, basically, to the front end, such that every endpoint then also would hit some business logic context layer that would have somewhere between 250 and 750 lines of Ecto queries stitched together with joins and subqueries and coalescing and fragments and whatnot, in a way that was far more complex than I think the data model needed. And at the end, there'd be these very special select statements that pull, a little bit of something here, a little bit of something there, a little bit of something somewhere else. And what we ended up with was, in terms of data access, files that were tens of thousands of lines long sometimes. That might be an exaggeration, definitely thousands of lines long, probably not tens of thousands, and where there were a bunch of very subtle variations. So getting this record in one context returned a map that had a slightly different shape than getting the record from a different context, which returned a map that had a slightly different shape from a record in yet a third context. And the way that manifested was every time we wanted to make a change, it was very, very hard to do so. It was hard to reason about the code base when there were, in a given query, dozens and dozens of subqueries, each crafted as their own beautiful special snowflake. And so that was kind of fun. It was kind of fun. We were able to make some improvements to that, but it was kind of fun. The last one, and this is one that I was actually responsible for creating in some ways, we had a microservice arrangement. We started with the microservice architecture very early on. But we did so too early, and we didn't draw the boundaries. We didn't understand our contexts, and we pinned ourselves into a place that was pretty hard to make changes. And it was pretty hard to know whether a piece of behavior belonged on one side or the other side of a given microservice dyad, which made accessing data really tricky. We ended up having to duplicate a bunch of data, which in and of itself is not bad. But it meant that things were more complex than they needed to be. So it's a couple of horror stories, small horror stories, and we've made a mess. We've made messes in a bunch of different ways. We have handwritten a bunch of SQL when perhaps we could have done something easier. We have not considered the shape of our data or not like done the work to model it just a little bit further to get us in trouble. And so we have the joy of getting our CRUD together. So let's talk about some motivations then. And so with all of this, and in my career as a software developer, most of the applications that I've worked on have been internal line of business applications that support at most a couple hundred users concurrently. Sometimes a bunch of users if it's the folks who are working internally as well as the customers, but at most a couple hundred users concurrently. So usually runtime performance is not a meaningful constraint that we have to work with in the applications that I've worked on. And my experience also has been that for most teams and most pieces of software, they're supporting relatively small user bases with relatively small performance demands compared to what the big players do. And so in those cases, optimizing for speed to market is useful. How do we optimize for the time between when a stakeholder says, hey, I would like you to build this thing, and when we say, yes, we have built it. It is out, it is done. We can spend all day tuning performance. We can spend all day tuning any of a number of things. But that is, for most teams, I think probably the correct thing to optimize for initially. And so then what that comes to is, well, how do we do that? One way I think that we can work with this is by trying to reduce non-meaningful variation, trying to reduce cases of, well, in this case, I called it get, in that case, I called it fetch, in this case, I called it list, in that case, I called it all, it doesn't really matter. If we can reduce those things, we can go just a little bit faster. If we can make life just a little bit easier in terms of the data plumbing, we can go just a little bit faster. If we can reduce cognitive overhead and make things more predictable, and that comes both in like the code that we use to do things, but also the shape of the data that comes back. If we can make that more predictable, we can go faster, and we can go faster because we're not having to think as much about the stuff that should be handled for us. And we can instead think about the actual problems we're solving, which is exciting. So in terms of motivations and kind of going through that, I was led to Bruce Tate's. Whoops, I guess I had slides about that. I was led to Bruce Tate and James Gray's book, Designing Systems with OTP, the Worker Bees book. And in it, we talk about a notion of layers. And so I'd like to kind of go through this just as like broader context. When I think about layers, layer 4 here, data access, is what we're going to be talking specifically about. But with most applications, you've got something that kicks off the work. It's an API endpoint. It is a recurring scheduled job, or not even recurring, just a scheduled job of some sort with Oban. It is a live view. It is a user interaction. It's a socket connection. There's some external stimulus that kicks off a unit of work. Below that, we've got some sort of container that work lives in. Most of the time, particularly for smaller projects, that container is just like the running application. In other cases, we may choose to split it off into its own processes. We may choose to split units of work off into a gen server, for example, or an agent or a task or some other thing that we can use to kind of isolate and atomize that. Most of the time, though, we can just run our code without having to worry too much about that, which is both good and bad. Below that, we have the notion of a bounded context, where a bounded context is it's a concept from domain-driven design. But the idea is that you've got some unified collection of concepts and work and data. So if I've got an application, perhaps billing might be its own bounded context. Perhaps user management might be a bounded context. For the Prairie application that we have, we'll have a couple of kind of implied bounded contexts. It's it's a test application for talk purposes rather than a real application, but where veterinary records for our beautiful bison might be one bounded context, and the bison themselves and the prairie, where it's kind of a logical separation along business lines of notions and concepts and language and the way that we describe things. Below that, the data access layer, how are we getting it? And then below that, some sort of functional core. Once we have the data, we can run it through a thing and then get information or effect changes or whatever we might need to do. And so this is one of many versions of a layered architecture. This is the model that it differs from Bruce Tate and James E. Gray's model. It's a model that, for the most part, maps pretty neatly to the work that I do. And so if we talk about the data here, I'm going to try to move pretty fast through the conceptual stuff before we get to the code, which we will here in just a second. Our data might live in a database. It might live in a gen server, as we talked about before, or an ETS table, or some other like or a process, some other in-memory thing that is running. Data also might live on some remote service or some remote third-party application. If you're using Stripe, for example, then credit card information does not live on your service, it lives on Stripe's service. And payment information lives out in the Stripe world rather than, I guess some of it will live in your system. But so our data might live in these places. There are probably other places that might live too. It could be in a file if you're using like an EDI, the electronic document interchange. There's a number of places the data might live, but these are ones where it commonly might live. And so with conventional approaches to data storage, some problems that we see, and we've kind of hinted at these already in the horror stories, but I'm going to make them more explicit. One is we'll see variations in data representation. The variations by themselves are not bad, but we will see variations that are not motivated by business need or not motivated by the needs of the context within the business. It ends up being, in some cases, you've got first name, last name coming back. In other cases, first name, last name get coalesced with a SQL fragment into full name. We see variations, and the more variations we have, the harder it is to reason at a glance about something. Not bad in and of itself, but everything has a cost. We might see things like failed bookkeeping after business events. So for example, imagine that a payment goes through, a subscription payment or a payment for a service or something. The customer is charged, but for whatever reason, that doesn't make it into your database. And so you show the customer as not having paid yet. The customer, by their bank account, shows themselves as having paid yet. Your bank account will also show them as having paid, probably not for a couple of hours. And so you can see, we see this failed bookkeeping with business events. That is, say, a divergence between what our representation of reality and actual reality. We also see sometimes with conventional approaches that small changes can have really, really huge effects. And things that are kind of hard to catch. And we'll talk a little bit about ways that might work. An example of this might be if you change the name of a field and you're using Ecto schema, Ecto structs, most of the time that change will be caught everywhere that it matters, and you'll be okay. However, if you change the name of a field and what you're using is a custom select statement inside your Ecto query, probably won't get picked up unless you have a test that catches it. Hopefully you have a test, but if you don't, you get to find out in runtime, and your users are the testers. And then finally, with conventional approaches, we sometimes see things like over-reliance on callbacks, which I was thinking about it while we were sitting here. And what I think I actually mean is what we see is a conflation between business logic and bookkeeping. And with bookkeeping, what I'm describing that as specifically is the idea that we're keeping records of things that happened, immutable records like an accountant might keep. Business logic is what happens with it. So the bookkeeping is they're on the database. The business logic is an email gets sent, a user gets access to something or gets denied access to something, a product gets shipped, any of a number of these things. And so what that comes into is some patterns. And all of this is still going to go like through, we will do code, and we'll do code very quickly. One pattern that I've found really useful is to be really mindful of, am I doing business logic here? Or am I doing like the implementation of bookkeeping? And with that, it becomes even within my context, does it matter to me if this record is stored in this table or that table, or if it's stored in a table, or if it's stored in a remote service, or does it matter that it exists? From a context perspective, probably shouldn't matter most of the time. We should be relying on something else to track the bookkeeping. Instead, we should be performing that business logic. Another pattern that I found useful is finding aggregates. Aggregates are another domain-driven design concept, but it's within it's your representation of data and related information within a context. So going back to the notions before, if we have like we have a user record, almost every we have user records within a user administration section. We have user plus their permissions. Within a billing section, with a user plus their payment methods and their payments. From a user doing stuff section, we have a user and the prairies they manage and the bison within their prairies and so on. When we find those aggregates, and when we're really intentional about what data we're bringing with and what data we're not bringing with, that helps us to write better software and it helps us to better manage things. And the converse of this is, what you see sometimes in very early stage like Rails applications, where you've got great whacking models with a bunch of data on them, and that data just comes with everywhere. And so finding those aggregates can be useful as far as like thinking what data I'm actually bringing forth. Composable queries are pretty fun. We'll talk about those. Taking what would be pretty closely mapped to SQL and making it look more like Elixir. And then some sensible defaults. And so an example that I'll propose here is the GenericRepo, which is one of many ways that we might do things, but it's a sensible default that can work well enough. And again, what we're coming back to is like, can we separate our business logic from our bookkeeping? This is kind of, this is explained by, in the worker bees designing systems with OTP book better than I will treat here. But the notion is, can we separate the stuff that has like the fact that things live in a database from the business logic that we perform on them? Most of the time we can. We've talked, I think, everything that I've meant to say about finding aggregates and contexts here, but again, it's just like a representation of data, but only the stuff that you need. And typically it's all going to be represented as a graph of Ecto structs with a top level entity. It's pretty exciting. Let's talk about composable queries. And so you may have seen these already. If you have, awesome. If not, also awesome. Terry, you are here. So they're pipelinable. Use the pipe operator. They often use the pipe operator. They take a query and return a query, and they end up reading like Elixir rather than SQL. I want to show you an example of composable queries in action. Here are a couple of queries. We've got this bison struct. A bison, I mean, if you're, I guess, not familiar with North American fauna, it's a big, shaggy buffalo looking thing. They're beautiful and huge. And we might want to query our bison so that they're at least some number of years old, or they're at most some number of years old, and so on. Oh, there's a typo. That's exciting. So we can do that. Let's take a look. So our base would be something like repo.all bison. That's just a list. That's not a composable query at all. But we can do some fun things here. So if we do Bison queries, yep, there we go. That's aliased appropriately. We can do something like Bison queries dot, what is it, default query. And then pipe that to Bison queries dot at least 3. And then repo that all. And what we'll see is that we've gotten rid of the babies. There are no bisons there are no bison younger than 3 here. And this little bit here, it's just Ecto behind the scenes, but it reads in a way that carries some semantic weight. This is kind of a trivial example because the age at least, it's not very hard to map that to a where clause, but it can get more exciting. Okay, so the bison within the United States, the state that I live in is Nebraska. Immediately south of us is a state called Kansas. Both have bison. So we might do something like bison who are in a state. That all. And from our data model, I should have shown you the data model first. So a bison have an age and a name. We've got some veterinary records. We'll talk about that later. They belong to a prairie. And the prairie has a state code as well as a name. When we're gabbing within the state, we're doing some pretty exciting things here. This is lines 22 through 36, where this is an Ecto query or an atom that happens to implement Ecto schema, or it's using an Ecto schema. We make sure the prairie is attached, and then we make use of a named binding to match against the state code. So it's what it ultimately ends up being is a join clause in the way that we might write. But again, it reads like Elixir rather than like SQL, which can help to make things just a little bit faster, particularly when our SQL is actually complex. This is not particularly complex SQL. When it is very complex, we can read like this. And we can make use of that has named binding. If we have prairie already loaded up, cool, keep going. Otherwise, we'll just do a quick join. These are things that you can do with your data models. These are things that you can do relatively quickly. And it gives us this really nice experience of writing code that looks like Elixir rather than code that looks like SQL. It makes it easier for the junior developers. It makes it easier to just write what you mean rather than having subtle variations sneak in. And it means that when you do need to change those variations, you change it in one place. Presumably it goes everywhere, but then you'll have to make some assessments as to whether that's what you actually want. Sometimes it is. Sometimes you need some other variants. But I've had some success, particularly on teams with a number of junior developers, in building out composable queries rather than asking them to write SQL. Even for junior developers who are pretty comfortable with SQL, I've had some success with that. And I think the reason that I've had success with that and the reason they've had success with that is because it carries semantic meaning rather than getting bogged down in implementation details. Which is kind of exciting. And it means that we can go faster and presumably do better work. So with these, there's some really great resources for composable queries. The Ecto book that the Prog folks put out has a really good treatment. There are also some great blog posts and articles. So this is the time that we'll spend on it right now, but we can work with it. And again, we're describing the meaning, we're standardizing the shape of data, and we're reducing some cognitive overhead, all of which mean that we can go just a little bit faster and a little bit more confidently. which I like. Another pattern that I found useful is the generic repo. And what that is basically is taking the function that the Ecto repo, your app repo provide, and putting a standard wrapper around it. This way you're calling things the same thing, and you're accessing things in the same way. And so functionality we probably want something like a list, get one item, create, update, delete, counting or averaging or some other aggregate function might be useful as well. And so I'll show you what that looks like. This repo, made a macro. I'll show off that macro here in just a sec. But we can grab our bison along with our defaults. So let's do something like this. Let's do a bison repo 1. We'll just grab the first one. Ideally, we'd have a sort mechanism here. We're not going to have one, but we'll grab one. And what we'll see is we get back a bison with some preloads here. And we can do some inspecting as well. This little like dot __ info functions, you can use that to explore any struct or any module that you create. It'll tell you your functions and their arities. It's useful if you're doing metaprogramming and you're not entirely sure what's coming up and what's going where. We can work with that. And so if we think about this amount of code for a junior developer relative to what you might see if you use the Phoenix context generator, there's less here. There's not zero. You still have to know how it works. You still have to know how to explore it. You still need to be able to kind of reason about it, but it becomes a little bit more predictable, especially more predictable if you're using this in line with other contexts. And a cool thing that comes up, so this is a repo that grabs Bison just like by themselves. We can make lots of repos. We can grab things. So let's imagine that we want like a veterinary Bison repo. For a veterinary Bison repo, we're going to get a single Bison or potentially lots of Bison. And we want to know their veterinary records as well as the staff member who made those records. And their prairie and whatnot, so we know where those bison are. We're still getting the same, we're still accessing the same table. But still underneath all of this is like a repo.one or a repo.all from bison and prairie.bison.bison. We're still accessing it all, but we get the different representation. And the generic repo itself, I'll probably release it as a library at some point, thing you can use if you feel so inclined. It is in the application, but let's take a look at it. Go to the core, got this generic repo. We're making use of this def macro using. That's so you'd make use of it with use. We're getting the schema. That's the name of the thing that we're querying against. We're looking at our default preloads, which we are defining. Let's looking at our default preloads. So we define that here. We might, if we feel so inclined, filter down our methods. So I've got this method list we can filter down against. This piece, I'm still figuring out how I want to handle it. So this way it becomes actually portable code rather than a thing that you need to make changes to before you can use it in your application. And from there, we'll do things like this. So If we're making use of the all directive, we will pass in a queryable, which defaults to schema, in this case, to query.bison.bison, and we'll get all of them. Or if we are able to insert, in some cases, you might want to constrain operations at the programmatic level so that these things can be inserted, these things cannot be inserted in this context, these things must be inserted in other contexts, and so on. You might want to constrain those options. Data for updating. But mostly, it's just a little bit of light meta programming, which becomes kind of exciting. A pattern, a place where I differ from the Ecto repo defaults. By default with Ecto repo with get, you're either getting the thing or you are getting nil. A preference that I have is for an OK tuple or an error not found. The reason I have this preference is because of the with statement that you can use in your context, where it is with this thing, unpack it with an OK tuple, with the next thing, unpack with an OK tuple, with the next thing, unpack with an OK tuple. Nil is really hard to match errors against, especially if you have more than one thing that could return nil, because you don't know, because it's impossible to tell from a nil what it could have been or should have been. Whereas an error not found, or even something like an error schema not found, which for us would be error pro.bison.bison found. That's something you can match against that error and make a determination about what should have happened or what could have happened, and then handle it appropriately. That's a place where I differ, I think, from get. It's not either way is fine. It kind of depends on what you're using it for. I like with statements, so I prefer the OK tuple and the error tuple. There's a number of others here. I'll let you, I can answer your questions. I want to make sure that I'm being somewhat diligent about times. I have a tendency to be long-winded. We also have some variants that we might play with. So this is the variant of, whoops, let's get our slides back. Instead of, we can return something instead of nil. We can turn an error tuple instead of nil. Another variant that you might see, I first learned about this from Steve Bussey's book about concurrent Elixir systems, also out from Prague. You might want to publish or have some sort of callback, like a pub sub thing, where you're publishing to channels, and perhaps your live views are consuming those channels and updating the page on the fly. So you could define something like this, where there's an update. And after you update, you maybe publish along with an action if it is so desired. Where from a publish, if we have an OK tuple, update, recall, returns either OK, some record, or error change set. If you have an OK tuple, probably you want to publish a success callback. If you don't, we can just pass the result forward, and this will still return an error tuple. We could do the same thing using the kernel's tap method. Tap, in my experience, confuses junior developers, and so I don't use it, and instead prefer do it this way. It's kind of up to you to decide what things you do and don't want to introduce to your team, really. Another variant for this, same basic thing, but instead of doing a default publish, we dependency inject some callback function. If it is a function and if it's an OK, we do it, and we do it on success. Otherwise, we don't, and we just return the result. Either way can be OK. This way can be a little bit more flexible for testing. But there's a number of ways we might do this. And that's, again, kind of up to you. The way the generic repo is built, you can change the code and have it change everywhere. You can introduce new flags. You can do things like that. And so other variants, an anti-pattern that I've seen with Elixir code bases, particularly those who were, or Phoenix code bases, I'm sorry, particularly those who were started by somebody who's doing like their first big project in Phoenix for the first time, and particularly if they're coming from Rails, is having one big change set per schema. And that change set just kind of handles everything. A pattern that I found to be more successful as far as managing change and as far as making change easier to reason about is having lots and lots of little change sets. So on your user page, a single change set to change their email, another single change set to update their password, another single change set to change their profile picture. And then, doing like a modal that pops up. Yes, here, change your email, here, change your password, here, change your profile picture, etc. And this is, it's going to be motivated by your user interface and your user experience needs. It's going to be motivated by, a lot of things, really. But by having lots of small change sets, you can make life a little bit more pleasant. And since our generic repo in the create and update or the insert and update functions, since they take a change set, it doesn't matter. You can pass any change set in and it will be just fine, which is kind of exciting because then you can use change sets at abandon. And in the context, you take your attributes, assign them to the right change set, put it in a multi or whatever, do your inserts. And then your repo, your data access layer, gets divorced just a little bit further from business logic, which is mostly good. Not entirely good, but mostly good. And again, another variant, and this is, I guess, just another urging, is like, don't be afraid to access the same data in lots of ways, and don't be afraid to build aggregates, knowing that your aggregate is going to have more information than you probably need on any given page. But if you've defined your contexts well, I'm not sure that correctly is possible, but if you've defined them well, then what you will be able to do is, excuse me, what you'll be able to do is make reasonable predictions that data will be there and reason about it, which lets you go faster. So here's an example of a couple of different things. And the thing that will vary here, the name and the preloads. So if we're just looking at regular bison, we might grab the prairie and the keepers and the offspring. If we're looking at the veterinary care, we might grab the checkup charts and the records and the veterinarians and the vaccinations. The last thing that I'll observe, and I think we're probably running pretty close to time now, is I think we're probably, we are absolutely running pretty close to time, is that as you're working with this, said earlier, like optimize for speed to delivery, and that's usually the correct choice for most teams. However, at some point for some teams, it's no longer the correct choice. And that's the point where having telemetry, having monitoring, being able to reason about system performance is really useful. Because then you can make your informed choices. If your product is successful, you will outgrow this approach. It's really great for getting from 0 to 1. It is not so great from getting from like 10 to 100. At some point, you're going to outgrow it. And that's okay. That's good. It's worth knowing, but it's also worth not buying things that you haven't yet grown into out of fear of outgrowing them. So that's a bit. The last thing that I'll suggest is that we can, if we so choose, make use of internal state like gen servers or ets tables or Redis or memcache or whatever to cache data if we have really expensive operations. And so going all the way back to the motivating factors, the real motivations here, and you can get there a lot of ways. This is a way that I have found, it doesn't have to be the way that you find, is that we can reduce bugs by reducing subtle and unnecessary variation. We can reduce cognitive overhead. If we can do those things, that means that we can go faster, we can have a better speed to market, and we can have happier stakeholders, because the thing that they asked for is possible today instead of tomorrow, or tomorrow instead of next week, or next week instead of next month. There are a lot of ways that we can do that. I found that standardizing data access, being really mindful about it, especially on teams of junior developers, is one of the most meaningful ways that I can do this. which is exciting. So I'm going to skip through these bits. I think the very last thing that I'll say is, again, places where we get in trouble is when we're mixing our layers of abstraction and where we are getting our implementation details mixed with our business logic. To the extent that we can separate those, life is usually pretty fun. There are other bits here, and I will make sure to do some write-ups about that. But right now, I want to make sure that I'm being mindful of times. I'm pretty sure that I'm a little bit over. And so this is it, I think, for the prepared book.